Hello and welcome to this video on solving for a particular variable, solving for a variable in a rational equation. Alright, so in this video I'm going to do a few examples where we have an equation or formula involving many variables and also having some fractions or rational expressions, right? Thus the rational equation. And of these several variables, we'll be asked to solve for a particular variable, meaning I want to get that variable alone on its own side, right? Isolate that variable and state what it's equivalent to in terms of all the other variables in the equation. All right, so let's get started. So my first example: solve the equation for the indicated variable. So here's the equation involving, three variables, r, g, and x. I have r equals, then a fraction here with a numerator of 4 times g and a denominator of x. And I want to solve this equation for x. Alright, for x. Okay, now there are several ways to do this, but I'm going to go through this in the same way I solved rational equations in videos I've posted previously on solving equations involving rational expressions. Okay, so I'll relabel the steps here. So first, I'm going to find the LCD, right, which is the least common denominator or the least common multiple of the denominators. Now, I hope it's obvious here. Because the only denominator with a significant factor, a factor other than 1, is this denominator here of x. So the least common denominator is, x. Simple as that. And I'm just going to point out to myself too that, we don't want this to be equal to 0, right? You never want denominators to be equal to 0. So I don't ever want the LCD to be equal to 0, implying that we cannot have the value of x be replaced by the number 0. Right? So x cannot be equal, is not equal to 0. Alright, okay, then multiply both sides by the LCD. And the reason for doing this is to change your equation with fractions into an equation without fractions, with denominators that are just 1. So let's see that happen here. So you see my left side is r, and I'm going to multiply that by the LCD, so r times x, which I'll just write as rx, equals, and then the other side is this single fraction, 4g over x, and I'm going to again multiply this by the LCD, and again make sure, and just note in my head that the value of x cannot be 0. Alright, because you can't multiply both sides of an equation by 0. That wouldn't mean anything, because you'd eliminate everything. You'd just have 0 equals 0 and nothing would come of it. You'd get no information. Now hopefully you're seeing here that when I do multiply both sides by the LCD, by this x, it'll get rid of all the denominators, right? All the denominators and this LCD have a common factor. Nothing's happening over here. This would just be rx. But over here, see, I have a factor of x in the denominator and a factor of x now in the numerator. Right? This is times x in the numerator. So those would divide away, divide out, and become 1. Remember, anything divided by itself, anything over itself is technically 1. And great, now we have this. I have now rx, right? R times x on the left side equals, and then after canceling out, dividing out the factors of x on the right, I'm just left with the factors of 4 and g, 4 times g. Right. And now it's solve the resulting equation. Now we're asked to solve this particular equation, for x, and that was given in the instructions. So I want to get eventually, what this means then is I want x equals, 1x equals, and then over here an expression on the other side, an expression containing all other variables. And I say the other variables, right? So no x over here. Right? So x equals, and then some expression that does not contain x. And this is what they would call a linear equation in x, right? You see an x here after I clear the denominators away. The power on x is to the first power. This is x to the first. And there's no other higher powers of x. So they would call this a linear equation in x. And when you're solving a linear equation, you gather all the terms with that variable to one side, which we have, this r times x. This is the only product, the only term with x in it. And all the terms without that variable on the other side, which I have done here is already done. It's 4 times g, that product, that term does not have x in it. And then you do some sort of multiplication or division to get x by itself. Right? And remember, what you do to one side, you must do to the other. All right, so in order to get x, this is x times r. In order to get x by itself, I'm multiplying by r here. I would then need to divide by r. And same thing on both sides. Divide by r. And the whole side. And then r over r, these factors of r's would cancel. And I'd be left with x equals, and then 4 times g in the numerator over here, divided by, and then r in the denominator. And there you go. This is exactly what I was talking about up here. This is solved for x. X is alone. It's 1x equals, and then an expression involving all the other variables, right? The g and the r, but no x's, right? Notice there is no x over here either. And again, you could point some things out. Point out that in the beginning, the value of x cannot be 0. And if you state x this way, the value of r couldn't be 0 either, right? You never want a denominator to ever be 0. Okay. And if you want to play around, plug in a value for g and a value for r, like plug in 2 for g and 8 for r or something, then you'd have 8 over 8. X would have to be 1 and stuff like that. Right? You can mess around with the values of the variables, but here's x solved for in this equation. Great. And it's the same steps, the same procedure I used for solving equations involving a fraction, right? Equations involving a rational expression in previous videos if you've been watching mine. All right. So here's another one. I just got a few of them. So here I am given an equation involving, again, 3 variables. There's this s, a, and r. So I have s equals, and then here's a fraction, a divided by, or over, 1 minus r in the denominator. And I'm solving this for r. Right? So I want to eventually get r by itself. I want r equals, and then an expression without r, right? And an expression on the other side that involves only a and s. Okay, so the LCD to start. Now, just as before, just as the last example, there's only one denominator here with a factor that's not 1, right? Technically, you could throw s as s over 1, say the denominator is 1, but this denominator here, 1 minus r, is it, right? So 1 minus r. And that, if you want to write it, say that's the only factor, you can put in parentheses or whatever. It's not necessary because it is the only factor. But the LCD is 1 minus r. And then again, like I like to do this, just point out to myself that denominators should never be 0. So if I don't want this denominator to be 0, that means the value of r cannot be 1, right? Because then if r were 1, you'd have 1 minus 1 or 0 in the denominator there, and that'd be bad. So I'll point that out to myself. So just so long as this 1 minus r is not 0, we can do the rest of this. Alright, so then comes the multiplication by that LCD. So the left side was s, and that is getting multiplied by the 1 minus r. Alright, the LCD, again, the whole thing, not put in parentheses, we're multiplying both sides by the entirety of 1 minus r. And the same thing on the other side, right, equals, and then you have a single fraction over here, so just a over the 1 minus r, and that is getting multiplied by the factor 1 minus r. Alright, so you've got a factor of 1 minus r in the denominator over here, a factor of 1 minus r in the numerator now. That would go with the a. So those would divide out to be 1. And so all I'm left with on the right side is the letter a, the variable a. And then over on this side, just simplify, we'll get rid of the parentheses here. I'd be distributing the s, right, to the 1 minus r. Alright, so what the equation looks like after I multiply by the LCD is I'd have s minus, and then s times r, or just sr if you want, equals a. Alright, and now if I were asked to solve for a, if this was a, I'd be done. Right, you see how I've got a alone, and then this expression over here does not involve a at all. So if I were asked to solve for a, I'd be finished. But I'm not asked to solve for a. I'm asked to solve for r. Now, after clearing the denominators, right, notice that the only term with an r in it has r to the first. So the highest power of r is, the first power. This is another one of those linear equations. This is linear in r. So I'm going to gather all the terms with r in it on one side, and all the terms that do not have r in it on the other. Well, there's only one term, one product that has r in it, and that's this negative sr, right? This is technically negative 1 times s times r here. Remember, subtraction is just adding the opposite. So I could really write this as s plus negative sr. So negative sr is the only term with r. So it's on the left side. I'm going to keep it there and take every term, everything that doesn't have r in it, to the other side. So I'm going to get rid of this s here, subtract s, and do it to the other side as well. So now I have negative 1 times s times r, right, the only term with r in it on the left side. And then on the right side, these are totally different variables, so these are not like terms. You just have a term of a and a term of negative s, a minus s. Wonderful. Then we can, now that I have the only terms with r on one side, everything without r on the other, I want to get 1r, not negative sr. So do a little division, right? This is r times negative s. We can divide now by negative s. And do the same thing to this whole side here, right? The whole thing, not just the first term, not just the second term, but both of them. Right, that entire side is divided by this negative s. Alright, and then what does this look like now? Well, you see on the left side, the factors of negative 1 will cancel, the factors of s will cancel, and I'm left with r equals, and then over here I have a minus s in the numerator, divided by, and then negative s in the denominator. And this is totally fine. You could call this done. I have solved for r. Right? R is by itself, r alone on one side, 1r equals, and then an expression involving all the other variables, the a and the s on the other side, with no r. But sometimes people don't tend to, people tend not to like a negative lead in a denominator or a negative sign in a denominator like this. So you could also do this where take the this is like -1 times s. It's like you have a factor of -1 down here. You could move that factor around. You can pull the negative out front. Say this is the opposite of, or -1 times, and then the fraction a minus s over, again, where this is lined up with the middle, lined up with the fraction bar. I'm just sliding this to be in line with the negative sign to be in line with the fraction over s like that. Okay, this would be fine. Or, again, all this is a factor. This is just a factor of -1. So what you have is -1 times a minus s. So you distribute the negative, and you have negative a plus s. Well, again, negative a plus s would be the same as s minus a in the numerator, and then divided by s in the denominator. And all these things are the same. Right? And you can test it out. Replace a and s with any numbers you want. Again, as long as s is not 0, right? Don't divide by 0 or have a denominator of 0. And see that this expression and this expression and this expression would all have the same value. Try it out. When s is 6 and a is 3, when s is 7 and a is 15, you'll see that all three of these things mean the same thing. And one other way you could also do this is by doing division, right? Remember, this is division, and if you recall, when you add or subtract fractions, the denominator is the same throughout, and the numerators get combined. So this s minus a over s, if I were to reverse subtraction here, this would be the same as s over s minus a over s, right? See the common denominator throughout, and then s minus a would be the numerator, right? So this here is the same as that, so you could write this as well. But then another thing I'm seeing is that s divided by s, that's just 1. So that's 1 minus, and then the a over s fraction. So I could write this as well. All these things are the same. This expression, this expression, this expression, this expression, all 5 of these expressions I've just written are equivalent, have the same value, no matter what you plug in for a and what you plug in for s, right? Just so long as you're not plugging in 0 for s, and test it out if you want. But there we go. I've solved for r, right? R on its own, by itself, equals, and then an expression that doesn't have r and depends on all the other variables, the a and the s on the other side, through the same procedure, same steps as I did for any equation with fractions. Alright, so I've got one last example here demonstrating solving an equation for a particular variable. Alright, so this one here, a few fractions. Now this one's a little different than the previous ones, because there are now there's more than one fraction with a denominator that has a variable in it. So I have 1 divided by f, 1 over f equals 1 over p plus 1 over q. And for this one I'm asked to solve for p. Alright, so I want to get p alone equals, and then something involving just f and q on the other side, no p. Alright, so first the LCD. I'm going to go through the same procedure. Now, if you were to factor all these, right, well, f is just f, p is just p, and q is just q. So the LCD would just simply be made up of f times p times q, or fpq, all to the first power. And none of those can be 0, right? F can't be 0, p can't be 0, q can't be 0. And I'll make that little statement here, right? I don't want any of these to be 0, because I'll have denominators of 0. I'll be multiplying both sides by 0, and that's not right. That's not good. Alright, so now comes the part where I multiply both sides by the LCD. And again, the reason for that is so we can rewrite our equation as an equation without denominators. So the left side, I have 1 over f, just the one fraction. times, I'm going to multiply that by the LCD, f times p times q. Alright, and then equals, and doing the same thing to the other side. Now the other side is a sum, it has multiple terms, multiple fractions added together. So we're going to multiply not just this fraction, not just that fraction, but the whole thing. So the I put in parentheses, 1 over p plus 1 over q, right, that whole thing is getting multiplied by the LCD, the FPQ. And there's going to be, since this is a product over a sum here, we're going to be distributing. And you'll see that all the denominators will go away, right? Every single denominator in a problem should, have a common factor with the LCD, should go into the LCD evenly and do some canceling. So, you're probably seeing that here, right? On the left side, got a factor of f in the denominator, a factor of f in the numerator, so you can divide those out, and what I'm left with in the numerator now is 1 times p times q, or just p times q. Right, so I'm left with p times q, or pq on the left. Alright, then on the right side, I'm going to be distributing, right, this fpq to each of these fractions here. Now, if you multiply the first fraction, if you multiply 1 over p by fpq, so you got a factor of p in the denominator, a factor of p in the numerator. So this p and this p will cancel, and I'd be left with 1 times f times q. I'd be left with just f times q in that first term. Plus, and then the same thing here, I distribute the fpq to the 1 over q. When I multiply 1 over q by fpq, you have a q in the denominator, a q in the numerator. The q's will cancel, and I'd be left with 1 times f times p, or just fp. Alright. So now I have a nice looking equation with no denominators. And again, remember, we're trying to solve for p, right? Keep that in mind. Now that all the denominators are gone, we can see that this is again a linear equation in p. Look at all the p's, or p to the first, p to the first. The highest power on any of the p's I'm seeing after clearing the denominators is p to the first. So it is linear, and I'm going to treat it as such. I'm going to solve it like I would any other linear equation. I gather all the terms that have p attached to it on one side. Well, there's already one of those on the left, right? P times q is a term with p in it. But there's also one on the right, this f times p. So I'm going to take that away. I'm going to take it to the left with the pq. So we're going to subtract this fp, right? It's positive already. Take it away. Subtract fp. Subtract fp. And now I have this. On the left side, there's pq minus fp. Right. And there's all the terms with p. And on the right side, when I get rid of the fp, all that's left is, the only term without p attached is f times q. Alright, so I've gathered all the terms with p on one side, all the terms without p on the other. And then, in the previous examples, all I had to do was a simple division. But there's a problem here, right? There was only in the previous examples, there was only one term with the variable that I wanted. Here there are two. Alright, and I'll put this little note out there. In a linear equation, which this is, right? Solving for p, it's linear in p. When there are multiple terms with that variable, we're going to factor that variable out. So when there are multiple terms with the variable, right? And again, when I say the variable, that means p here, right? The one we're trying to solve for. Factor that variable out. So that's what I'm going to do. Alright, on this side there are multiple terms with p in it. That's a common factor for both these terms. I'm going to factor p out. So p comes out as its own factor times, and it's just, you're just reversing the distributive property. When I pull p out, the other factor remaining would be q minus f. Alright, and you can double check that, distribute the p times q, you'd get pq, and then minus, and then p times f, you get fp or pf, right? Equals, and then over here still just fq, right? Didn't do anything to that side. And now comes the division part. Now I have a single term with p in it, a single product with p in it, right? Just these two factors. And then here's where the division comes in. Okay. Now if I want p alone, I got to get rid of this q minus f factor, and it's being multiplied, so to undo that I divide by the factor q minus f. Now since it is the only factor I'm dividing by, there's no need for parentheses. You can put parentheses around this if you want, but there's really no need since it's the only factor I'm dividing by. And then same thing on the other side, divide that fq by q minus f, and then we're done, right? You see now there's a q minus f factor over here, they cancel, and I'm left with p on the left side all by itself equals, and then this fraction here where the numerator is f times q and the denominator is q minus f. Alright, and again, just remember that f can't be 0, p can't be 0, q can't be 0 from earlier. And another little thing that you would probably mention is that q minus f can't be 0, right? Denominators can't be 0, or q can't be equal to f, right? So if you go through and replace values, replace f and q with some numbers, you couldn't replace q with 3 and f with 3, you'd be dividing by 0. You couldn't replace q with 5 and f with 5, you'd be dividing by 0. So whatever you replace q with, you can't replace f with that same number. Alright, so there you go. There's this equation that we started with. Alright, this crazy one with the 3 fractions up here. Solved for p, right? I've got p alone equals, and then on the other side there's an expression involving just the other variables, right? No p, f and q, right? F times q divided by q minus f. Alright, so that's just a few examples. Great, I went through, and notice I went through the same procedure I went through to solve any equation with a rational expression. Find the LCD, multiply both sides by the LCD to clear away denominators, and then solve the resulting equation. If it's these ones ended up being linear, sometimes you might end up with a quadratic or a cubic or something else. And there's other ways to get around that, but we'll see that in other videos, I'm sure. And as I like to say at the end of these, try your best, do the best you can to get and understand the material on your own before you go looking for help. Because I have found that I find that people tend to remember things better. It tends to stick with you more if you've put in the hard work and you took the time to try to learn it on your own. So read through the material, read through the examples an author gives, and maybe even try to work out the solutions to an example problem before you read what the author did to see how that goes. Learn from your mistakes and stuff. Practice problems that are exercises from the backs of sections. Look for ones that have answers provided so you can check yourself. And if after, and don't just give up after the first attempt. Don't get super frustrated so easily. If after several attempts at a problem it's still not clicking, perhaps you should go back and read through the material once more. Maybe even a third read through. And make it a little more slow and deliberate, the reading. Because maybe there's something you missed, or maybe maybe something will click the second time or third time through the material that didn't click the first time. And maybe it'll make it that much easier to work on the problems. But if after several read-throughs of the material, several attempts at some problems, and you're still not getting it, it is not a sign of weakness whatsoever to go asking for help, to go looking for help. That is what other people are there for. So ask a teacher, a tutor, friend, somebody else who's in the class that you know knows the material. Look for supplemental materials online, Google things, go find videos on the subject, videos such as this one, or plenty of other videos out there that are better than mine. I assure you they're out there. Just keep at it, keep persistent, keep practicing, and try your best to have fun with it too. Because if you go in saying, I hate this, I hate this, I hate this, I've always hated math, well, you're going to keep hating it. Try to go into something. I know it's hard, but try to go into these session, your homework sessions with the mindset that with a positive mindset. I'm gonna try to enjoy this. I'm gonna try. Maybe I'll learn something. Maybe I'll have fun with this. Maybe I'll get something that I can apply later to something else. Just try to have fun. Keep persistent. Keep practicing. Have a good time, and I know you'll get it. I just know you will. And thanks for watching.